Picture a beach on the Mediterranean. Warm water, a few boats, somebody swimming out past the buoys. Hold that picture. Now take the water away, all of it. 6 million years ago, if you stood on that same spot, you would not be at the edge of a sea. You would be standing at the lip of a desert, a baking, salt-crusted basin sinking away below you for 3 kilometers straight down. No water, no waves, just a vast dry hole in the middle of the planet, hotter than Death Valley, white with salt to the horizon. This is not a myth. It's not a thought experiment. There is a layer of salt up to a kilometer thick buried under the floor of the Mediterranean right now. And the only way it got there is if the entire sea dried up. We drilled it out in 1970. And when I first read what those cores meant, I genuinely didn't believe it. A whole sea, gone. How does that even happen? Start with the sea itself, because the Mediterranean is stranger than it looks. It feels permanent. It's ringed by some of the oldest cities on Earth, but geologically, it is barely hanging on. Here's the problem. The Mediterranean sits in a hot, dry part of the world, and the sun pulls more water off its surface every year than all the rivers flowing into it can replace. The Nile, the Rhone, the Po, every stream in southern Europe and North Africa. Add them all up, throw in the rain, and it still isn't enough. The sea should be running a deficit, drying out a little more each year. So why doesn't it? One reason, the Strait of Gibraltar, that narrow gap at the western end, only about 14 kilometers across, where the Atlantic leans in and pours water through to top the basin back up. That thin doorway is the only thing keeping the Mediterranean full. It is a sea on life support, and the Atlantic is the machine doing the breathing. Put a number on it. Across a whole year, the sun and the dry winds lift roughly a meter of water off the surface of this sea, more than the rivers and the rain hand back. Left to itself, sealed off, the Mediterranean would lose something like a meter of depth every year, year after year, no matter how many rivers tried to save it. The only thing papering over that deficit is the Atlantic, leaning in through that one narrow gap and quietly refilling the tank. Now, what happens if you close the door? Around 6 million years ago, that is exactly what started to happen. And it's worth knowing the connection back then wasn't even Gibraltar. It was 2 other seaways, one running through what's now southern Spain, the Betic Corridor, and one through northern Morocco, the Riffian Corridor. The whole region here is tectonically alive. Africa is grinding slowly north into Europe, and that collision was buckling the land upward, pinching those corridors shut one after another. At the same time, the planet was sliding into a cold phase, and ice was locking up water at the poles, dropping the level of the global ocean. The land rose, the ocean outside fell, and at some point, the last gap choked off. The life support switched off, and the sea began to die. What happened next has a name. Geologists call it the Messinian Salinity Crisis, after the town of Messina in Sicily, where the salt rocks were first studied, and it ran from about 5.96 million years ago to 5.33. Once the Atlantic was cut off, physics took over, and physics was merciless. The sun kept pulling water into the sky. The rivers couldn't keep up, and the Mediterranean started to fall. Not gently. Think about the numbers. Strip away the Atlantic, and this basin can lose enough water to drop its surface by meters every year. Over a few thousand years, a blink geologically, the shoreline doesn't just retreat, it collapses. Whole gulfs empty. The sea pulls back from the land in every direction at once, and what it leaves behind is not beach. It's the deep floor of an ocean basin, suddenly naked under the sky. And that floor was deep. In places, the Mediterranean is over 4 kilometers deep today. Drain it, and you get the lowest, hottest dry land the planet has seen in the age of mammals. A chain of scorching basins more than 3 kilometers below the level of the world's oceans. And think about what the air does down there. Drop 3 kilometers below sea level, and the atmosphere itself piles up on top of you, denser and heavier, and it heats as it's compressed. The bottom of that basin would not have been warm. It would have been an oven, air temperatures that plausibly ran well past 50 degrees Celsius, maybe far higher in the deepest pits, a dead furnace of salt and rock with a sky shimmering somewhere kilometers overhead. Nothing you'd recognize as a coastline. Just glare and heat and white crust cracking in every direction. And the rivers? The rivers went mad. A river only cuts as deep as the sea it drains into. Drop that sea by kilometers, and every river feeding the Mediterranean suddenly has thousands of meters of new downhill to chew through. So they cut. The Nile carved a canyon into the bedrock beneath what is now Cairo, a gorge that, at the site of the modern city, plunges around 2.5 kilometers down. There's a buried canyon under the Rhone in France just as dramatic. Engineers found the Nile one when they were drilling for the Aswan High Dam and hit river gravels impossibly far below the surface, in solid rock, where no river should ever have reached. A canyon to rival anything in Arizona, and it's completely invisible, packed full of younger sediment, hiding under one of the most famous cities on Earth. Here's the thing that gets me. People lived their whole lives on top of that buried canyon and never knew the ground beneath them was the record of a vanished sea. So how do we actually know any of this? You can't see a desert that's been underwater for 5 million years. You drill into it. In 1970, a research ship called the Glomar Challenger was working the Mediterranean, punching holes into the deep seabed and pulling up cores, long cylinders of the layers below. Two of the scientists leading the work were a geologist named Kenneth Shue and a marine geologist named William Ryan, and what came up the drill pipe stopped them cold. Gypsum, then rock salt. Thick beds of the stuff, the kind that only forms when seawater evaporates away under the sun. Not at the edge of a sea, where you might expect a salty lagoon, but here, on the deepest floor of the basin, a place that should never dry out, and it was the details that nailed it. They pulled up nodular anhydrite, a lumpy, knotted texture geologists call chicken wire, and it forms in exactly one setting, a coastal salt flat baking in the sun, a sabkha. They found stromatolites, the layered crusts left by microbial mats in shallow, sunlit water. They found ripples of wind-blown silt and cracked, sun-baked surfaces. Every clue pointed the same impossible direction: shallow, scorching, hypersaline ponds, sitting kilometers down on a seabed that today lies under cold, black, crushing, deep water. There was only one explanation, and it was almost too big to say out loud. The entire Mediterranean had dried into a salt desert, more than once. The cores showed cycle after cycle, the basin drawing down, crusting over with salt, a trickle of water returning, then drying again. It was such a wild idea that not everyone wanted to believe it at first. A dried-up Mediterranean sounded less like geology and more like a tall tale. But the rock doesn't argue. The chicken wire gypsum, the stromatolites, the deep basin salt, they only form one way, and that way is a sea evaporated under the open sun. Sue, Ryan, and their colleague Maria Sita published the case in 1973, and it rewrote the history of the entire region. A sea everyone thought of as eternal turned out to have a death certificate written into its own floor. And the scale of the salt is hard to hold in your head. Buried under the Mediterranean seafloor is a salt layer that in places approaches 1.5 kilometers thick. Add it all up across the basin, and you get something on the order of 1 million cubic kilometers of salt. Geologists have a name for a deposit like that. They call it a salt giant. And this one is so enormous that when all that salt came out of the world's seawater and got dumped here, it measurably changed the chemistry of the entire global ocean, pulling out something like 5 to 6% of all the salt dissolved in every ocean on the planet. For a while, the rest of the world's seas were noticeably less salty, because so much of their salt was lying here, drying in the Mediterranean sun. Let that land for a second. A regional disaster in one sea, and it reached out and changed the saltiness of the entire planet's ocean. To grow a salt bed a kilometer thick, you have to evaporate a column of seawater dozens of times over. You fill the basin a little, you bake it dry, you leave the salt, you do it again and again. The arithmetic only works if the Atlantic was leaking back in and getting shut off, over and over for hundreds of thousands of years. The salt isn't a single event. It's a metronome ticking through deep time, each layer one more cycle of a sea being born and killed. This didn't happen in an afternoon. The crisis ground on for something like 600,000 years, the basin filling a little and drying a lot, over and over, laying down its layers like rings in a dead tree. Toward the end, there was a strange in-between world the geologists call Lago Mare, Lake Sea, when brackish water crept back in, and the deepest floors became a patchwork of vast, weird, shallow lakes, neither ocean nor desert. Snails and tiny shelled ostracods adapted to that odd, low-salt water have turned up in the cores. Species with relatives over in the ancient lakes near the Black Sea, life rafting in along the margins of a sea that had mostly ceased to exist. And then even that flickered out, and the basin went quiet and dry and waited for the Atlantic to find a way back in, and then it came back, not slowly, not gently. Around 5.33 million years ago, the barrier at Gibraltar finally gave way. Maybe the land subsided, maybe the rising Atlantic found a low point and started to spill, maybe both. But once the water began to move, it did something almost unimaginable. It carved. In 2009, a team led by the geoscientist Daniel Garcia Castellanos published the evidence in the journal Nature. Buried across the Strait of Gibraltar, they mapped a channel, an erosion scar around 200 kilometers long, gouged into the rock by water on the move. And the numbers they reconstructed for that water are difficult to even picture. The Atlantic didn't trickle over a dam. It tore a canyon through the strait and came through in a flood, the Zanclean flood, refilling a basin 3 kilometers deep, possibly in a matter of months to a couple of years. And the cruel twist in the physics is that it would have started slow and ended in a frenzy. As the water cut its channel deeper, it ran faster. The faster it ran, the more rock it tore out. The more it tore out, the faster it ran. A runaway. The model suggests that the great majority of the entire Mediterranean, most of that 3 kilometer deep emptiness, refilled in the final violent fraction of the whole event. Not centuries of gentle rise, a switch thrown. At its peak, the water level across the Mediterranean may have climbed by as much as 10 meters a day. A day. Picture standing on a hill above the dry basin and watching the waterline rise past you faster than you could climb. The discharge through Gibraltar, by some estimates, ran to around 1,000 times the flow of the Amazon, the single most powerful river on Earth today, concentrated into one roaring gap 14 kilometers wide. Not a vertical waterfall, exactly, more like an immense ramp of white, accelerating water, kilometers across, pouring downhill into the deepest dry hole on the planet, and not stopping for the better part of a year. There would have been a sound to it that no living thing with ears ever heard, and I'm almost glad we weren't around to hear it. A continuous roar for months as the Atlantic refilled a basin the size of the Mediterranean Sea. In a geological instant, the desert was a sea again. The salt deserts, the buried canyons, the strange low lakes, all of it drowned under more than 3 kilometers of returning water, and the Mediterranean we know was born. That flood marks the boundary line in the rock between two ages of Earth's history. One sea ends, the next one, ours, begins in a wall of Atlantic water. So here's what I keep circling back to. Everything about the Mediterranean day feels old and settled and finished. The harbors, the ruins, the idea that this sea has simply always been here. And under all of it, a kilometer down, lies the salt proof that none of that is true. This water has been gone and come back. The map we treat as permanent is just the most recent draft. And it raises a quieter question. If a whole sea can vanish and refill and leave its only record buried out of sight, how many other salt giants are sitting in the planet's crust right now? The ghosts of oceans we've never named. They're down there, under deserts, under seabeds, in the dark. If that idea pulls at you the way it pulls at me, subscribe, because this channel goes after exactly that, the enormous things hiding one layer beneath the obvious. Go back to that beach, the warm water, the boats, the swimmer past the buoys. It's still true. It's all still there. It's just that the sea they're floating on is younger than it looks, and it arrived in a flood, and a kilometer below their feet, the salt is still waiting, patient, white and certain, to remind anyone who digs that the deep history of this planet is not finished, and never was. The Mediterranean dried up once. Nothing says it can't happen again.